Alright guys, so tonight we're going to look at the ideal gas law and how the ideal gas law differs from the previous gas laws which we've looked at. Now, the ideal gas law, well, first off we need to know what is an ideal gas. And ideal gas is an imaginary gas which conforms to all the assumptions of the kinetic molecular theory. To review what the kinetic molecular theory assumptions were, please refer back to your notes from chapter 13. Now, the ideal gas equation is PV equals nRT. P is pressure, V is volume, N is the number of moles, R is a constant, and T is temperature. Now, R is the ideal gas constant, and the value for this is 0.0821, and the units for it tell you the units that all the other pieces have to be in. The units for the ideal gas law constant are liters, so volume must be in liters. Pressure is atmospheres. Moles, and then temperature must be in Kelvin. So if the units or the measurements for pressure is not in atmospheres, you need to make sure you convert those units to atmospheres. If it's not in liters, you need to convert it to liters. If it's not in temperature Kelvin, you need to convert it to Kelvin. If you don't do those conversions, this constant won't be right, and you will not be able to use the ideal gas law constant or come up with the correct answer. We're going to do a sample problem to help guide you. Now, what's the difference between a real gas and an ideal gas? Well, an ideal gas right now is imaginary. So when can we have a real gas that's going to behave like an ideal gas? And at a very high temperature and a very low pressure, real gases will behave most ideally. So what I want you to do, or what we're going to do now, and tomorrow we're going to work on the ideal gas laws worksheet, is we're going to figure out how many moles of gas are contained in 89 milliliters at 21 degrees Celsius and 750 millimeters of mercury pressure. So the first thing we're going to do is I see a volume, so I'm going to write down volume, 890 milliliters. I see a temperature, so I'm going to write down my temp. I see a pressure, so I'm going to write down my pressure. And I don't see anything else. So what I see here is one gas under one condition, and we're talking about amount. So one gas, one condition. Because of this being only one condition, it's got to be the ideal gas law. All of the other gas laws that we looked at, we're talking about one gas under two different sets of conditions. So that's why we had an equal sign, and we had the variables were equal on each side of the equation. For now, since we have one gas, one condition, we know it's the ideal gas law. PV equals nRT. We know that our R is 0.0821 liters times atmospheres divided by moles times Kelvin. So we're going to put that right into our equation. We're going to put in our N for moles because that's what the equation's asking for, how many moles. Now for temperature, we look back at temp. We see we have degrees Celsius. We have to add 273. This is going to give us 294. So our temperature is 294. We have a measurement of milliliters, and we have to convert milliliters to liters. So we're going to divide by 1,000, since there's 1 liter, there's 1,000 milliliters. So we have 0.890 liters. And our pressure is in millimeters of mercury, 750 millimeters of mercury. And we have to convert that to ATMs. So 1 ATM divided by 760 millimeters of mercury. And this is going to come out to 0.98. So going to have to rewrite my equation here, but 0.98 for pressure, volume is 0.890. That's going to equal N times 0.0821 times 294. We're going to isolate our variable. And you are going to solve for the number of moles that this comes out to. Now, the great thing here is once we have the number of moles, we can convert moles to grams if we knew what substance this was, because then we'd have our molar mass. All right, so come up with an answer for this calculation. I'm going to ask for it on your quiz on Wednesday, or on your mixed gas laws review quiz tomorrow or Wednesday, depending upon when you're taking it. So you're going to have the sheet out on your desk when you take the quiz, and I'm going to expect that answer there. All right, have a nice night.